Welcome to Haxby Shed. When I adjusted the spindle bearings on my lathe, I found that I had a problem with lubrication at low RPM. So I made a transparent cover for the gearbox and I can watch what's going on and I can show you what the problem is. This is looking down into my gearbox and the only feed to the spindle bearings is this splash channel here. And it runs down there, and then there's a magnetic plug and it runs past that and down into the spindle bearing. But it relies entirely on oil being splashed from the gearbox onto this ledge and into this splash channel. I'll set it going and show you the problem. I'm going to start at 34 RPM and build up from there. And I can tell you that no oil is going to get onto this ledge until we get somewhere around 200 RPM. That's 120. Well, we just started to get a little bit of splash at 130 RPM. Let's take it up a bit more. Well, we got to 150 and still nothing going on the ledge. It's just getting onto that ledge at 250 RPM. Now, a number of people suggested that if I use thinner oil, I might not have that problem. The oil that's in the gearbox now is ISO 68 hydraulic oil, which is the equivalent of the old Shell Tellus 33, which is what the lathe had when it was made in about 1970, something like that. It's quite thick, and when the weather's cold, it's really quite thick and gloopy. Now, a number of people have suggested that I'd be better with ATF, and I did think about that for quite a long time. I've kind of come to the idea that ATF is meant for automatic transmission, and also some versions of ATF are not yellow metal friendly. Now, there's a lot of bronze in my gearbox. There are not many ball races, ball bearings, taper bearings on the shafts. Quite a lot of it is hardened shafts with bronze bushing. So I was quite concerned if I used an oil which wasn't yellow metal friendly. And I was watching Double Boost, John, his channel. He's got a Harrison 140 and he was using Royal Purple oil. So I did some research on that and I found that there were two versions of that oil that might work in this case. One is called Synchromax and the other one's called Gearmax. Now, Synchromax is intended for manual gearboxes as I understand it, and they're both yellow metal friendly. I went for the Gearmax version, 75W90. If I put the thinner oil in the lathe gearbox and it lubricates at low RPM, then happy days, nothing else to do, job done. But I'm suspicious that won't be the answer. So I bought myself this little gear pump from eBay, which we'll take a look at in a minute, which I'm powering from an old PC power supply. But before we get to that, I want to just test the difference in the thickness between the oils. And I'll do an experiment which you've probably seen on YouTube many times, but I think it's worth just looking at it because these are my choices of oil rather than something just theoretical. I've put 50 millilitres of ISO 68 hydraulic oil in here and we'll just see how long that takes to run out. Go. So I'm timing this on the stopwatch on my phone. I'm afraid this isn't very exciting for you, but it'll get better. 26 seconds for that. So now I'm going to try the ATF. So this is ATF 2364, which goes in my son's BMW ZF gearbox. About 18.5 seconds for that one. versus 25 for the hydraulic. Now let's try the Royal Purple. So here's the Royal Purple. Guess what colour it is? It's 9 degrees centigrade in here, 48 Fahrenheit. Okay, let's test this one there. 1, 2, 3, go. Well, this isn't going to solve the lubrication problem, I don't think. It's just made a big hole in my pocket, that's all. Because it's about 25 quid a bottle for 1 US quart. About 51 seconds, whereas the ISO 68 was 25 seconds, I think. So here's the pump and 2 pipes. I bought this strainer. I think it was about £10. It's very expensive actually, but it's stainless steel with a brass fitting. And the idea is that that would just lay in the bottom of the gearbox and strain the oil that was being drawn up. Obviously it gives some resistance to flow. We'll see how we get on. It's my intention to set this lower down the lathe, and therefore you'd get a gravity feed through this down into the pump. The oil in this can is the ISO 68 hydraulic oil, so we'll see how we get on with that. Watch what you're doing. I'm not going to demonstrate the other oils with the pump because I'm just getting oil everywhere, and you can see that it works. It strains a little bit, but having this power supply from a PC in the lathe could be really useful because it gives me 12 volts, 5 volts and 3.3 volts I think. And my son suggested that I could install a radio with a large subwoofer, but I was thinking perhaps, you know, air horns or something like that. So next we need to look at the gearbox itself and see where we might put the pipework. By having the pump external and easy to access means that if this pump isn't really powerful enough, I'll just look for another. I can upgrade it any time, once I've proved the principle. We're a day further on, and I'm still trying to justify spending £50 on oil which was thicker. I have a plan. This test that we did, the viscosity test, this had a very thin nozzle on it, and I'm just thinking perhaps there was some boundary condition which made the oil a bit sticky. You can see I'm making this up to try and justify what I've done. But I've got this other which has a bigger hole in it, and we'll just try that. So I'll put 50 millilitres in and we'll time it into here. Give me a second to set it up. Okay, original oil from the gearbox. Right, 6 seconds. And now the Royal Purple. About 11 seconds. So, yeah, about 2 to 1. These, by the way, in the UK are about £25. When I looked at royalpurple.com online, buying from the States, it was $16, but I can't buy direct because they won't ship it. So somebody's doubling the price before it arrives here. It's often the case. You see something in the States $100 and over here it's £100, but it's not normally double. The ratio is about 1.37 to 1, I think, at the moment.
I'd convinced myself that the ISO 68 oil was thick, but looking at this table I can see that the 75W90 is 1.6 times more viscous at 40 degrees C. In fact, ATF is only about 30% thinner than ISO 68.
For the oil feed, I'm thinking about making a manifold, so I've got a block of brass to do that. I've got these fittings, and the thread is 1/8 BSP, and they have an olive and they take a 4mm pipe. And if I put this block within the lid, maybe this area somewhere, and then all I need to do is to run pipe work that runs really just onto this ledge here, and then another tube pipe going to the left hand spindle bearing, and then another just going onto the clutch bearing. And if I can keep all of that within the lid itself, it minimises interference with the main body of the gearbox. Now I'm going to have to think about the pickup, and the pickup is probably going to have to go towards the back. The oil in this gearbox is really quite shallow, maybe only about that, if you can see my fingers, there we are, only about that probably. And when the lathe is running in the forward direction, all the oil gets pushed to the back over here. But when the lathe is in the reverse direction, the opposite's not true. You just see the normal oil level at the front. So to be sure that the pickup would always be in oil, it's going to have to go in this back corner somewhere, down at the bottom of the gearbox. So I've got to figure that out. And then the pump itself, I'll try and put as close as I can to this block, so we keep the pipework short, because obviously it's a lot easier to run electric cables up to this corner perhaps than it is to run copper pipes everywhere, which will restrict the flow, cause too much drag on the flow. So what I'm going to do now is take the end case off the lathe and just have a look where we might put the pump and where we might put the oil pickup. 5/16 Allen. This pulley I made is doing all right. Right, as I look from here, I can see some of this wood. So without cutting any metal away on this casing, I could possibly get a couple of pipes in there. You can see that wood there from the lid. I could cut more of this case away if necessary without damaging anything. I'd then have a couple of short copper pipes coming out, coming into PVC tubing around here to the pump. When I wanted to take the lid off, I just pull the two tubes off and it would come away. There's about 1 inch of oil in the bottom of the gearbox. And when I check my strainer, that needs about 20 millimeters of oil to sit in. So if the strainer sits right at the bottom of the box, it might be okay. Or if I can lay the strainer on its side, I don't know yet. This motor, these holes, they're nice brass fittings, but the hole in there is under 2 millimeters. And I think the pump's got more capacity than that. You probably saw that the flow was a bit strained, so I'm going to see if I can improve these. This is what I'm talking about. If I unscrew these, the hole, if it will focus, is about 2 millimeters maybe, but that doesn't go all the way through. But if I turn it over, you can see that thread there. It's only about a 3 millimeter thread. So I'm looking at making some replacements for these. But I want to get the cover off the gear pump and just see how much material I've got to play with. There's very little in here. Just this black driving gear, this white driven gear, a labyrinth of passages. And I just want to check the size of these passages. The galleries are about 2 millimeters wide. This is a 2 millimeter drill. The front plate on this pump is actually quite thick. There's quite a bit of material to play with there. And I've got some brass 2BA screws which I might be able to adapt. No chance. Oh. Now to consult the Zeus tables and look for the tapping drill for 2BA, which is 4 millimeters. 1976 metric revision. I hope it still works. I decided that 2BA is taking up too much real estate, so I'm now threading it down to 4 millimeter by 0.75 mil pitch. Good morning. This is where we got to yesterday, making these replacement pipe connection fittings, and I'm going to leave that for now because I'm going to take a look at the oil feed supply within the headstock for the spindle bearings and think that through and finalise the design. The minimum that I need to do, in fact, is to run a pipe from here across here and deposit oil onto this ledge. It would run along this channel and feed this spindle bearing. But I'm going to take the opportunity to lubricate this bearing, the left-hand ball race for the spindle, and the ball race for the input shaft, which is just sitting this side of the clutch. This brass block would be machined to make a manifold, and it would need to sit somewhere like this. It can't sit over this side because there's a screw hole here which bolts the lid down. This bearing is pretty much directly under the block, so perhaps just a little spout off this would be enough, and the oil would just trickle down on here and trickle down into the bearing. If I put a fitting here, the pipe could come out and come this way, and ditto the other side to take a pipe back here. I could simply solder in a pipe coming from this hole out of this casing here. I only need fittings, really, olive fittings, where I think I might need to make some adjustment. And my idea is that I would fit this first to the transparent case so I can see where everything lines up, and then fit it to the aluminium case. I could tune it with the transparent case on. It may be that I need to close up the hole in the end of this pipe just to balance the flow between the back bearing and this spindle bearing. And I drilled just quite a small hole in here for the feed for this bearing. That's kind of the thinking at the moment. Here's an idea developing. This fitting here, 8th BSP fitting, could go in just below where it is now, with a pipe coming across within the lid, and with a bend on here, just tucking it behind where this screw hole is. And then I'd put a similar fitting on the front face just to the left here, and then potentially one on the end to take the input pipe. Right, I think I'll have a go at that. I'm just going to square the ends of this block off in the shaper. That looks pretty good. These were thread adapters that I put in for a different job. I was converting from 8th BSP to 1/4 Whitworth 20. So let's see how tight they are, because I don't need them for this job, obviously. Oh, not bad. Wow, that's pretty good. They were Loctite and pressed in on the press. Clean those up with a 1/8 BSP die, and I can make sure it's not cross-threaded. It's going okay. Yeah, that's fine. This is the layout I've decided on, and the feed will come in at one end like this. The tapping drill for 1/8 BSP, according to the Zeus tables, tells me 1132 or 8.75 millimeters. So it'll be 1132 because that's what I've got. Just doing the third pilot hole, I've set a drill depth. That's 3 tapping holes done. They look quite good. I'll start tapping each hole in the drill press just to keep everything vertical. That'll do, I think. Right, get the other 2 done now. So there's the manifold with the 3 fittings for the 3 pipes. I haven't cross-drilled it yet, for the chamber going across. I'll do that later when I know exactly what I'm doing. And this will fit about there. And I'll have a couple of screws to hold it. I've got some countersunk Allen screws, 15mm long, M4 by 0.7 pitch. So a couple of those will secure this. Now, because of the angle on this casting, I'm just having to set this edge away from the bottom, but I just need to make sure that this other edge here isn't going to be touching. So I'll drill one, thread it, screw it up, position it, drill the other, thread it. So that's the first one tapped. I'll just drill through and mark it, and then I can work from that. Okay, that's fixed on. So the next thing is to figure out how the feed pipe's going to come from this side and into here, and what I'm going to use for that. These are each 4mm. I'd like to use something more like 6 internal if I can. To bring the oil feed into this manifold block, I've decided to use some of this 8mm copper pipe, and I'll need to put a bend in it to bring it round here and out of this side. And then I will solder a piece of this onto at the end of it to give me a pipe barb. I'll have to machine down this little bit here to 6mm, and I'll cut it off by here, just giving me that length of barb, which I'll then solder into the end of this pipe. So to do this, I've had to buy a pipe bender for this size of pipe. And of course I'm going to have to bend the 4mm pipes, so I bought another smaller pipe bender to bend these pipes. Anyway, we'll put this one to one side and we'll get on with this. There we are, and a bit of silicone round here will seal it. So now I need to drill a hole in here to take this pipe when it's bent. I've drawn this up and you can see it's going to be a bit tight. Pilot drill. Now an 8mm end mill. Now a 6mm end mill to create an offset pocket to start my 6mm drill. Well, I got there in the end. I drilled into the first 2 fitting sockets with a 5.5mm drill, and then into the last fitting socket with 4mm. The problem was that as I was breaking through, it was pulling the drill offline. And if I'd been a bit smarter, I would have drilled this one first. It's going to be okay, I think. Let's have a look. Carry on. Right, see if I can get this bend right now. I've got plenty of pipe, so I can have as many goes at it as I like, really. It needs to bend from about there, I think. And I guess R must be the middle one, but I don't know how that's going to work. Let's see. It's not making a lot of sense to me. Oh, that's 0 on that one. Ooh. So when 0's there, it seems to be 90 degrees. Well, that's quite close. Problem is the bend's really not quite fast enough, but I'll work around that and get it to fit. I found this pulley which might give me something a little bit tighter to bend around. Okay, that pipe's in place, not soldered. All I need is this barb to stick out of here, so I can pretty much cut this pipe off flush, and that'll make it a bit easier. How I'm going to get this lined up to solder, I don't know. I'll have to think about that. I don't think I can do it on here. I'm a bit worried about melting it. Some bits have just arrived for this project. A 1-inch BSP plug, a 1/4 BSP hose tail, and a 1/4 BSP by 8mm fitting with an olive. And either using this one or this one, I'll make the feed from the gearbox to the pump. Anyway, back to this. So I'm going to cut this here, and I'm going to use this hose tail here. I'm going to solder this end into my copper pipe here, but I need to machine this down to 6mm, and I'm going to do it on my other lathe. This is my other lathe. It's a Super Adept, and they were made as home hobby lathes, I think, between 1933 and 1961 by a company in Sheffield, England. And this was given to me by my wife's grandfather in about 1979, I would guess. And I barely ever use it, but for the first couple of years I was making lace bobbins. So here's a couple of my lace bobbins, if that will focus. There we go. And I used to glue various woods together and use this as a wood turning lathe. Bobbins were quite expensive at the time, so we used to buy blanks and I'd machine them up. So I've got a load of blanks here, and I use these chisels for wood turning, and these blanks are all different woods. Anyway, today I'm going to use it to machine a fraction off that brass barb. There's various, well, this is a 4-jaw chuck, you can see that. There's a steady rest there. There's a 3-jaw chuck. There's a tool rest that I made some time ago. A couple of different spindles. There's a centre there. It would have been driven by a belt on this pulley at one time, but I connected this bit of hose here onto the end of the spindle shaft and mounted this motor up. So that's about a 1953 GC 6 horsepower motor on a couple of rubber blocks, and I made these rings to hold it down, which I think are from the differential main output shafts from a Mini. Trying to get the work centered in the 4-jaw is a bit tricky, but I think I'm there. Oh, very naughty. I left the chuck key in. Whew. There we are. So the next job is soldering. Now I've checked. The melting point of the solder is about 250. The melting point of the aluminium is about 650. But I don't trust myself, and I could get point heat on something. If I melt this case, it's curtains. I don't think I'd ever get another one. So I'm going to have to solder this on the bench. We'll do this hose tail first. I don't solder every day, so it will get me back into practice before I do the other end. To try and get this lined up right, I've put a scribe mark on the pipe, but I've also put a little dot on this block, and if I line up the scribe marks and the dot, I should get it at the right angle. Place your bets. Well, the chances of getting this right on the first attempt are not very high. I'll solder it up and we'll see where we get to. Well, there we are. First go, actually. But there we are. So let's just try it on the gearbox. See if that pokes out in the right place. Well, it's going to need a slight relief by the look of it. I'll just use a round file and just take a fraction off that corner there. But otherwise that looks alright. Yeah. I filed that casing away to give it plenty of clearance so it'll take the diameter of the tube as well. Now I can move on to the oil pickup from the gearbox. Here's where the 1-inch BSP drain plug goes, and I'm going to arrange a feed from that in 8mm copper pipe. The plan now is to run an 8mm copper pipe from the drain plug down the back of this panel and coming out somewhere here, and for the pump to be in this area now, and then a pipe to run from this fitting just PVC clear pipe from this fitting down here and down to the pump, and that'll give me my circuit. So this is the old plug, but I bought this new plug just in case I mess up. I don't want to be left without a plug for the lathe. So I can always put this one back in any time I want. And this is the fitting which will fit in there. So I need to drill and tap that out now. We'll start with a 3mm pilot drill, and then the tapping drill is 11.8mm, which I don't have. But I do have a 1532, which is 11.9, so that's what I'll use. Now I've got a taper tap and a parallel tap. I'm going to use the parallel tap because I think that will give me more freedom in terms of setting the angle that I want to take my 8mm pipe in the right direction. I'll start it off in here for as long as it will go, which isn't very long, look. But that'll do. It's going quite smoothly, that. I could have used the tapping head if I could have been bothered to set it up, but it didn't seem worth it for one hole. Okay, that went well enough. Perfect. The next question on my mind is, can I incorporate this strainer somehow? It certainly goes in, works well enough. I could solder this into this somehow. I have a plan, actually. Maybe. It means the two wouldn't come apart, they would be forever in here, but that doesn't matter. Right, this is the plan to incorporate the strainer. I'm going to use a short length of this 8mm copper pipe. I did think about putting that in nice and snugly, but I've realised that the oil level will be too close to the top of this mesh. So I'm actually going to make this so that this pipe bends down. Now you might say, when I've finished tightening this up on the taper, it could be pointing down or it could be pointing up if it's a bent pipe. But no, because I know that I need to be down at about that angle, and that's where it will finish. I'll make sure it does. And at that point, this will be bent down. Just setting up, nothing soldered yet, but you can see that this is bent downwards, and this is set at 90 degrees to this. And so this should just bend down to the bottom of the box. Okay, I'm just about ready to solder this end. If you can see, as I rotate it, look, this is orbiting up and down. What I found was that there's a gear in the lathe headstock about there, so I couldn't have this pipe as bent as I wanted. But I've done it now, so that's how it'll be. And it's set so that when this is at the lowest point, this is pointing off to the right, because that's where I'll need it. And it just gets me a few millimetres of extra oil depth above this. Done. That's fitted in place, nice and tight, plenty of PTFE tape. And right down in the bottom of the gearbox there is the strainer, just above the bottom, peeking out between those two gears. Good morning. I've drilled myself an 8mm entry hole into the case where the pipe will come in, and I'm starting to straighten the pipe, which is on a roll. Doesn't have to be perfect, but straightish would be nice. There we are. Right, second bend. I don't know about you, I often end up bending my pipes the wrong way, going this way instead of this way. Anyway, this one is right, and I've lined it up this way so it doesn't go like that or like that. See where we get to with this. That lays about flat, so it's not far out. Maybe slightly twist, not much. In fact, how about that? That's near enough for Haxby Shed. So I just need to cut that short now and then machine this down on my other lathe and solder it on. Put a bit of flux on it. Do you say soldering or soldering? I looked this up. Now, don't shoot me if I get it wrong, but apparently the original Latin origins would have had the L, like soldering, but the French lost the L, so that became more soldering. And then the French invaded England in 1066, well, and in time, you know, all posh people spoke French, so it was dropped and became something like soldering. But apparently in the UK, in England in the 1500s, it became fashionable to sound a bit more Latin, so the L crept back in again. So that's what I read, but I'm sure my granny used to say soldering, and she was born in the late 1800s. So anyway, if you're a professor of languages at Oxford, maybe you'll let us know. Right, that's all connected. So the next thing to do is to transfer the brass manifold from the aluminum lid to the transparent lid, so I can see what I'm doing to set the internal pipes up within the lid. Bit of fiddling around, but got there in the end, and I'm satisfied that this block is in exactly the same place as it was on the other aluminium lid. So now I can fix up these feed pipes to the spindle bearing and the other bearings. It's been a fair bit of work, but I've managed to get the pipes in the right place. One's gone into that bearing at the back there. One pipe is just coming down onto the left-hand ball race on the spindle, and this pipe is going across the front here and nicely dropping into that runway. And because I believe that manifold block on that transparent lid is in exactly the same place as it will be on the original aluminium lid, if I set all the pipes here and transfer the block across, they should all go to the same places. They're fitted now with a bit of Loctite on, so I'll just put this back together. When I bought this on eBay, it said it was good for water and oil, and look what's happened to the O-ring. Luckily, I've got some others that will fit. All back together, so we'll pick up on this tomorrow now and hopefully get it working. We're getting very close now. I've put this big grommet around the pump, and I've used a bit of bronze welding rod so I could put a screw through there just to hold it for a test if I need to. I've connected up the feed from the gearbox and put this clamp on. So now it's time to put the oil into the gearbox. Number 2. Get every last drop out of that. It's a fraction above the line. Here comes the oil. Okay, now we're going to find out if the whole thing was worth it at all. So you can see this tube here is full of the purple oil, which is now priming the pump. I think I've got the pump connected the right way around now, because it was the wrong way. And we should watch for the oil being pumped up here, behind these gears, round here, and into the cover. So, 3, 2, 1, go! Da, da, da. Well, it's a bit noisy, it's struggling, isn't it? But it works. I don't think I can stand the noise for very long. Let's have a look in the head. The oil is coming out. Oh yeah, I can see the oil running down. The pump will probably burn itself out shortly. I think it's time to take stock. Overall, I think this has gone much better than I expected. It's certainly entirely feasible. The oil pump is too small. Also, it's not continuously rated. But it was only about £6 and it's proved the whole principle of the thing. So, you know, it did its job. The pipework within the lid went better than I expected. It's probably overkill to set up feeds to all those 3 bearings. And if you don't have a transparent lid, which maybe you don't, then it's easy to set up a pipe from this corner to the spindle bearing at the front here without the need to see within the lid to set it up. It's obvious where it needs to go. The oil is too thick. I made a bit of a schoolboy error with that, but there is some good news. My son needs to put new oil in his car gearbox, and he probably won't pay me much money for it. I might not save money, but I will save face. We'll leave the oil in here for a while, keep an eye on it. Let's just see when I manage to get the new gear pump. If it isn't soon, I may well drain this out and go back to the ISO 68 oil. So overall, I think it's worked very well. And I hope it was useful to you. Thank you for watching Haxby Shed.